Nasema they ended mysteriously. The student said when it ended mysteriously. Hello, good afternoon. Can anyone hear me? Please confirm. So I don't want to start talking to myself. Okay, thanks. I read you loud and clear. So, okay, I want to go back to where we stopped before we had a mishap. And it was about caching and the remote service. And so we had discussed about network file systems. And we said that you can have files that are cached, or you can have files that you have by remote service. Caching means you have them at your local station. Remote service means that you do everything and the information remains at the server. So you have that updated continuously. So that's where we stopped before we had a mishap. So I think I want us to pick up from there, and then we can be able to maybe field questions. I hope you had time to look at some of the maybe issues so that we can be able to look at how to solve those ones. So in our discussion, we mentioned two things there. So we had caching, okay? And then we had where many remote accesses are handled efficiently by a local cache. Now, what that simply means that if I cache a document, I can access it faster, okay? And so it means that it's at my location. And we discussed about two ways. You have a write-through policy where the moment you make a change, it's sent back to the server. And then we had a delayed write policy where when you make a change, it can be sent back to the server later. So when you are caching, servers are conducted only occasionally, okay, occasionally. So that means we can reduce server load because the server can focus on other things, and basically it will only be able to handle a request when it comes later. And of course, you reduce network traffic. That means that you enhance scalability. Scalability, you're saying, I can have the different clients located far and wide, and because I am not continuously accessing the server, I can have that to be wider. So it can mean geographically, or it can also mean having more nodes connecting. On a remote service view, this one handles every remote service access is across the network. So when I make any change, that information has to be sent to the server immediately. And so we end up having what we refer to here as penalty in terms of network traffic. Of course, you increase server load, and of course, you degrade performance. So when you're looking at this, if you are given two examples, maybe for example, which one would you want to use, caching and remote service? You have to look at these two things, okay? What are the advantages of caching, and what are the advantages of remote service? And of course, what are the disadvantages of both techniques? So that is the best way to use to decide which of the two techniques you can use in terms of implementation. So we might extend that, okay, the two aspects, and we consider it in terms of maybe the data, okay? So if I have to carry large chunks of data, okay, across the network, that will be a problem, okay? Transmitting large chunks of data, especially when you want to use for caching, can be a problem. Because remember, caching means I have to have the whole file saved on my location, okay? So it means that if I have large chunks of data, I would rather use remote service because that means I have closeness of data. So there's another way of also looking at it. If I have sensitive data that I don't want to be copied, I might also decide to use remote service. So So caching also is superior in cases where we have infrequent writes. So if I'm not writing continuously, I mean, I don't want to change my file. So supposing I'm the only one using that particular file, and then it's not being changed often. So caching is much superior to that. Okay, so I will cache it and I can be able to use it for long periods of time. Okay, so benefit from caching when execution is carried out on machines that either have local disks or large main memories. So again, it means that basically, before even you start thinking about caching, you also might want to think about what amount of storage space you have. Okay, so because if it's not enough, then caching might not be helpful. Okay, and of course, you might also be thinking there are cases where maybe you also have cases where you have diskless components. So in this case, therefore, caching might be a problem. Or even you have small memory capacity machines. And therefore, if you have a scenario like that one, then it means that you end up using a remote service method. So which one is the best method? Which one is not a better method? It all depends on several things. You have to consider the environment of the server. You have also to consider the environment at the client location. And then looking at that, you can decide which one is the best option. So you don't just say, I want to use caching, or I want to use remote service. You also have to consider about that particular node and the environment, the capabilities, and the space before you decide which one is good. So so if someone asks you, which one will you go for, caching or remote service? You need to interrogate and find out, okay, what are the characteristics or what are the advantages of caching, okay? Or in which environments does caching work well? On which environment does remote service work well? So in that case, you can now be able to say, I am going to use caching because of A, B, C, D. For example, I can use caching because I have a larger, maybe a storage space. I can use caching because maybe this file is infrequently being updated. I can use caching because maybe this file is small, so I don't have to have large chunks of data being carried across the network. Okay, so, and of course, if I have a poor network where traffic can be a problem, again, I can use that as a reason. So decide based on facts, not just simply saying, I'm going for caching without thinking about some of the reasons why caching is good. Now, when we are on network file systems, we need to be able to know that the interaction of the clients and the servers is such that we have to know which clients and which servers are you interact with. So for any file that is being transferred, for any file that is being worked upon, we must have the client and we must have the server. And so it means that therefore, we need to think about it in which ways does the server remember, okay? So this brings us to the concept of stateful and stateless servers. Stateful and stateless servers. So what is the difference? A stateful server remembers client data, okay? So it means that if a client connects to a server, a stateful server will remember it was client A, it was client B, and it was client C, for example, okay? So it remembers that particular client and the details. A stateless server, on the other hand, keeps no client information, okay? So what it means that the moment you have a request, the moment the server has finished with your request and replied, all that information is lost. So the stateless server does not keep information about the client. Okay, so using a stateless server therefore means that the client must specify complete file names for each request. Okay, so it means that if you're making a request using on a stateless server, okay, it means you must provide all the details every time. So even if you interacted with the server a short while ago, you must re-authenticate, okay? You must authenticate on every request because the server does not remember that the client made a request a short while ago. On the other hand, a stateful server will remember that client A was here and it made a request, and therefore I remember this client is from this particular location, has this particular maybe information, was requesting this particular file, and it might mean that you can simply continue, if you wanted to download a file, just continue downloading that file from where you stopped before. So in this case, therefore, you'll find that the stateful server remembers the client. So what is the advantage? So it means that when, for example, we know files, or from what we have discussed, clients will fail, servers will fail. So a stateless server is more robust, okay? A stateless server is more robust in the sense that even if we have lost connections, you cannot leave the server in an invalid state, okay? It does not leave the server in an invalid state because every request will have to be full, okay? Full. But when you have now a stateless server, even if you lose, even if that particular server goes down, when you come back, you'll have to make full request, arguments, where you are, what kind of maybe client, what is your request. So every time is a full request. So there's nothing that you are having orphans. We'll discuss orphans later on. A stateful server will have an orphan. If a client fails, the stateful server remembers I had client A, I had client B. Now it keeps on searching because remember, it has to return an information back to that client. So it keeps on searching. Where did the client A go? Where did client B go? So that means that we are saying an invalid state, and therefore it keeps on holding unnecessary information. A stateful server does not remember anything. So the moment it goes down, everything, when you come back, you will have to make a full request, and hence it does not leave any invalid states. So of course, there are disadvantages that we have for that, and that's what we want maybe to look at, okay? So let's consider the stateful service. So we are saying this is a service that is provided by a stateful server. So we call that stateful service. So what happens in this case, when you make a request, okay, a client opens the file, server fetches the information from the disk, okay? Remember, a server provides a service, and the client gives a connection of a unique identifier, okay, to that particular client and the open file. So a client the server knows client A was looking for this particular file. So there's an identifier. So if you come back again, that's what I was mentioning earlier on. If you come back again, it will say, oh, client A was looking for this particular file, and I can simply go back and maybe start from where it stopped before. So that means subsequent requests will be used. So you'll use that particular file and a unique identifier for subsequent requests, okay? And so, of course, that means that when that request is over, you'll have to reclaim main memory, okay? When the client is still is inactive, okay? So that, and that's what we have here. Clients who are no longer active, the server must reclaim memory. But the problem with that is that supposing the server is not aware that this client maybe has failed, it cannot be able to destroy that information. And that's why we are saying a stateful server still maintains invalid states when even some of the clients are lost. What are the advantages that come with this? Of course, fewer disk accesses, because remember, since the file, you have a unique identifier, okay? So we talked about here on a unique file, okay? So when you come back, that information is available, and therefore you can easily be able to go back and continue. local storage on the server is there. And so that means that you easily can be able to, so the services can be faster. Stateful server knows if a file was even opened for maybe sequential access. And when you come back, it can easily be able to even lead you to the next blocks. And so that means that requests can be done much, much faster. Services can be provided faster. So stateful service has those advantages. So again, if someone is saying you want between stateful and stateless server, what do you want? Which one will you choose? Again, you have to consider the characteristics of the stateful server or the stateless server before you make a decision. So unless, of course, someone might have said, I am starting with this and I have a stateful server, why would you want to use it? Okay, so on the other hand, if we're using a stateless server, okay, it means that every request is fully self-contained. So every request you say, I am client A, I'm looking for this particular file. Maybe this is the kind of course, it comes with information about your XDR, remember, external data representation. So all those things about marshalling and the rest. Remember, something I've not mentioned here is that we are using remote procedure calls. So the concepts we discussed earlier about remote procedure calls are the underlying concepts, okay? So it has fully to be fully self-contained to make sure it handles it. So every request identifies the file and the position of the file. So if your power fails, again, it will have to start afresh, okay? It will have to start afresh. So no need to establish and terminate connections by open and close. So it means that the file in stateful service, when you started, you had those ones done, okay? But in stateful server, no open and close operations because everything starts afresh, and therefore you can easily be able to access the information if you have all the necessary details to ensure you get that info. Otherwise, you cannot be able to get that particular file. Now, I mentioned something about, I mentioned something about failure. Of course, something that is very common in distributed environments is failure of files, failure of clients. So we need to think about those two servers, stateful and stateless. And then we'll consider the concept of failure recovery. So a stateful server, okay, loses all volatile information in a crash. So if you had a stateful server that had kept information about all its clients, when it fails, it will lose all that information, okay? So when you start, okay, you have to have a recovery protocol, which means dialogue of clients, dialogue with clients or about operations that were underway when the crash occurred. So it means that it have to find a way to restore. And the restoring means you have to start finding this particular client, which client was I dealing with? And so from where and so forth. And then you establish the dialogues that were there before you can recover. So server needs to be aware of client failures before this can be done. And in some cases, it might not happen. You might not be aware that the server, a client has failed because it depends on which procedure you had. Because if you didn't have a remote access method, it's not contacting you occasionally. Caching might take time, or if you had delayed write-up technique. So it means that it will take time. So the server might not be aware. So it means that the server will have to employ, after some time, you might have to employ what we call orphan detection and elimination. Orphan detection, you have to find, oh, this particular request I have, is it an orphan? Okay, so an orphan means you have a request and the client has failed. So you cannot be able to service. Even if you had a result, where do you take it? And so you have to have a scenario that will help you to eliminate that wasted space, okay? And then from that, you can be able to now to use that particular location. So this is something that we're going to discuss later on about detection and elimination to ensure that the server does not keep unnecessary information. On the other hand, a stateless server does not leave the server, okay, under server failure, it does not leave, invalid, okay? It's almost unnoticeable. What does it mean? If a client fails, the server might assume something else happened, and it will continue. When the client comes, it will still come with a full request, okay? And the server can now be able to handle without any difficulty because there is a full request that is coming in. And like we have said, the server handles, expects full requests from the client. So it does not notice much. So every time even if a client fails, it will just wait, continue with the services. When the client comes back, it comes with a full request and it will still continue with the request. The stateful server, when the client comes back after it failed, it will come back because it was dealing with this particular server. It will assume the client knows me already. So I don't have to go and introduce myself and say what I was looking for. It just comes, I want this with a particular request where it was. And this is why we are saying that it leaves it in an invalid state. So, so the penalties, there are penalties that are involved in stateless, okay? So we are looking at some of those characteristics. So this, in a robust stateless server, well, remember why it does not remember anything, it means that it has to have longer request messages. Think about it. Every time I have to come and interact with you, I have to introduce myself, I say what I want and all. So that means that it will be longer. But if we have interacted, I just come in, maybe I have an ID, looking at my ID, you know, oh, this is what we were handling, this is the request that we made, and we can be able to proceed with the request. So it is a longer request time, slower request processing, because the request processing will mean the request has to be broken down. It's like, even if you look at it from path name translation, which server was sending that, which client, which is a kind of, let's say, for example, the architect of that location and so forth and so forth. And of course, there might be additional constraints which are there because of the distributed file system. Every distributed file system might have constraints that vary from one to another. Okay, so that means that penalties that are there. So despite the fact that it does not leave a failure of a server does not leave an invalid state, but it has these penalties that someone has to consider. So if you are asked to design, again, you have to think about it. So which one can I live with? Which one is better in my environment for me to be able to employ? But as we're looking at those, sometimes you don't have the luxury to decide which one to use, okay? For example, some environments are inherently stateful service. For example, if you want server-initiated cache validation, server-initiated. So you are saying in server-initiated cache validation, you are saying that the server must know the caches, must know where the caches are. Okay, so it means that in that case, this particular state ensures that we need to know, because you cannot use the server to initiate validation unless the server knows where the caches are. So that means that you must know which clients were connected to you. So it means in this case here, we are saying that the caches here, so we are saying it maintains a record of which files are cached by which clients. So inherently, it must be stateful. And in some cases, Unix descriptors, okay? Descriptors are those files, and those files that they describe where those particular files are located and how they're structured. And the implicit offset shows where a particular file begins and where it ends. So it might be in terms of blocks. So this block ends here and this block ends here. So Unix file descriptors and implicit offsets are inherently stateful because it has to be able to maintain information about where the descriptors are on the nodes, and of course the current offset of that particular node. So for you to be able to know that, then it means that it must be stateful. It must be able to have the information, okay, about that particular client. So Unix descriptors and implicit offsets are inherently stateful. And in cases where you're using server-initiated caches, it must be stateful because it has to remember that information. Okay, so I think I can be able to just fill a few questions, something that is not clear, so that we can be able to maybe pick on that. So we have, okay, so now, so the first one of, the first instance of a stateful server, I have given an example of Unix, okay? Any server that is set up using Unix. So you can extend that to Linux kind of servers, okay? So those are examples. So if you set up any maybe Linux environment, okay, or Unix environment as your server, that definitely will be an example of a stateful server. Okay, stateless servers. Now, look at an example where you have a connection or online, okay? And then you have a setup. Let's give a simple setup where it does not allow you to be able to cache, okay? And this is one thing maybe we'll have to pick up later on. So when I cache also, let's use an example of cookies. If I am using cookies, I'm actually trying to keep information about that particular server, okay? So on both sides, okay? So I'm remembering where you are. So any server, if it does not allow you to have any cookies, okay? Or for example, then it's employing stateless, yeah? So it means that when you go back, you have to remember. And that's why, for example, even if you also set up an environment and you say, I'm not allowing maybe cookies, that's also what you're saying, stateless. But something that you have to remember is that when you are setting up these servers again, yeah, we are not inherently saying that you can only go for stateless or you can only go for stateful, okay? It's possible to be able to combine. You have the ability to have both of them. But now what it means, that the thing you have to remember is that we can also be able to employ the concept of stateful and stateless based on particular files. For example, I might be in an environment, I'm saying, I have these particular files and I'm not allowing you to cache this particular file, okay? So it means that I'm saying that whatever you do, this has to be stateless, yeah? So potentially we are saying, like I gave an example of Unix, which is stateful inherently for some of the aspects, but it's also possible, yeah, for you to set up to be stateless. So that is one possibility. So even when you are using HTTP connection and you are saying that, oh, I'm not allowed to have caching that information or keeping cookies, that's one example of being stateless. Okay, any other maybe question? And as we will look at some of these, as we explore other possibilities, we can search and discuss other examples, yeah, on maybe stateless and stateful servers. Okay, so let's try to look at some applications of network file systems, okay? And as we're looking at these file systems, we are trying to now implement. And so we started with the servers, okay, stateful or stateless. And also we talked about caching and remote, okay, remote access. And then now we want to see the different file systems that employ these techniques. So one of the examples is what one of the examples of network file system is this, the one that is employed by Sun. Okay, so Sun operating system runs an example of a network file system. And this particular file system uses a UDP protocol. Okay, so, and you know the behavior of UDP, basically you're saying that I'm not interested in terms of setting up my connection in the sense that I can use any route. Okay, so remember UDP, we always focus on best effort. Okay, so you can use whichever route. So now a network file system, yeah, uses a UDP protocol, and it allows you to be able to access remote files across local area networks and wide area networks. So how does this work? So first, the network file system uses, first of all, works with interconnected workstations that are independent of one another. And of course, we only allow sharing of file systems in a transparent manner. Remember the concept of transparency, okay? So it means that we don't have to know where those files are located and which are the clients. So that's what I mean by a transparent manner. So, and it means that if I have to access a file, okay, I have, let me put it this way. I have my local station, which I'm connecting, and I have the remote location where the file is located. So the remote directory, which I want to access, can be mounted on a local directory. Now, I'm going to explain this in a short while. Mounting means that I make it possible for you to see the files that are on a remote directory without changing the structure of the remote directory. So it means, therefore, it becomes like an integral part of my local system and descends from my local directory. Remember, descends, so if you started, okay, let me use something else. If you started and you had a file that had a local directory, when you have files that are mounted, your local directory changes to give you a view of what exists on the remote directory. But for you to be able to see them, they must be mounted. We are going to talk about mounting in a short while. And mounting must be done in a non-transparent manner. Non-transparent manner means I have to know the server, I have to know the file system that is used, okay? I have to know the host name of that particular location. I have to know the remote directory before I can mount. And the moment now it's mounted, then the access becomes transparent. So mounting must be done in a transparent manner. So I have to know all the details. And then now, after that, the access is transparent. So it's done seamlessly, and I don't have even to know it's happening because it was done, it's being done transparent. But originally, before you do that, you must be able to, first of all, mount that particular file. Now, mounting also is subject to some access rights accreditation. So you can't just mount. And that means that it gives us an opportunity to say, client A can mount files while client B cannot mount some files. So if we are two different clients, our directory will look different based on our access rights. Remember, the mounting allows us to have that information on top of my local directory. So let me just use a diagram. We'll look at that. We'll get back to that diagram later on. But let's maybe use it to explain so that you understand the concept of mounting. So this is our server, okay? And on this particular server, I'm saying this part here is what can be mounted, okay? So this server is saying you cannot have access to all the files. So For example, mounting, suppose, let me use something that, okay, let me use this one here. So this can be a location to mount. This can be a location to mount. So this one is saying you can only be able to mount from steam downwards, okay? And what it has done, it has said client B can mount. You can see that client A can mount. And you notice that when you mount those particular files, you can see this one was putting at that location, this one was putting at a different location. So these two clients, A and B, and remember that from here, this is our local for client A, and this is our local for client B. The directories, you can see, they're all different because when you have whatever is mounted, it descends from the directory of the client. So in this case, what we have assumed that the server allows client A and B to mount the same files here. This is what we assume, okay? But it is possible to have client B mount that alone, and maybe client A might be able to mount the whole of this. That's what I mean by access rights. So when the server allows for mounting, it will have to decide which of these clients, which are the access rights for each of those clients, and then it gives us an opportunity to be able to mount those files. So, and that's what I mentioned earlier in my last slide, it will be different depending on the client. Now, there's something else that is there to remember, that when you mount, okay, when you mount, client's view does not affect the server, has no effect on the server. Remember here that the clients did not change. The clients did not change what is on the server. No, they have not done anything to that. So the server still remains with that same directory structure. The most important thing to remember there is that when you come back with the information, you now have to think about it in the way this information that is being brought back. We have inconsistencies. You are changing A, I was changing B. When you bring the information back, or we are changing file A together, but you are changing at a different location from mine. When we bring back, how do we consolidate this information back to the server? That's what we call consistency. We'll have to think about that. It's a discussion and it's on later on. So when we're talking about mounting, one of the things that we have to remember that each of those different clients can mount it in different locations, okay? Can mount that in different locations of those particular files. So I'll come back to you, Julie, later on. Let's finish something, and then we can be able to solve that. So the network file system, as we have discussed, operates in a heterogeneous environment, okay? So different environment. So it means that we have different machines, different operating systems, and different architectures, okay? So that's what we mean by the heterogeneous environment. So the NF specifications are therefore independent of the different media. It doesn't care whether you have a machine that is using Big Endian or Little Endian, which operating system. All it does is that it will work with you, depending on, will work with you regardless of what you have. We'll see how that is done, okay? We'll see that, how it's done. But that independence of working with these different environments is through the use of remote procedure primitives. Primitives are things like open, close, okay, seek, far. So those things that we mentioned when we were looking at remote procedure calls, those are called primitives. They allow you to be able to access a file. So you'll open, you can close a file, you can read a file, you can write a file. okay? And that runs on top of what we call external data representation, XDR. Remember the concept we discussed some time back, which was marshalling. So external data representation is meant to do the marshalling. Marshalling is conversion from one maybe architecture. One data from a different architecture to a different architecture. So this means that now it gives us an opportunity to have what we refer to as implementation independent interfaces. Regardless of which architecture you have, it is implementation independent because the remote procedure calls will run on top of XDR protocol that will change whatever environment parameters or environment data you have to ensure that whichever server is handling that can be able to understand what you're speaking, okay, or what you're requesting. So NFS, when it's working, has to differentiate between two aspects. Are you using mount mechanism, or are you using remote procedure calls? So mount mechanism, your file appears as part of your local directory, so you can make changes on your local directory location. Remote file access, you're accessing that file, but that file is stored on the server location. So the changes, as we have talked about, you are handling those changes, but the file is at the remote location, not on your location. Mount mechanism, I have it. And that's why if you look at our diagram earlier, let me come back here, okay? If you look at this diagram here, we have that this view and this view are different, okay? Based on the directory, the client location, okay? So the views of the clients are different based on the different clients themselves and the directory that they had. So, but it does not change. None of those clients is changing the server directory. So what we are saying, client's view does not have any effect, okay? Does not have any effect. So I think this one I was supposed to have written does not have effect on the server, okay? It does not have any effect on the server as you are making any changes to it. Now, how is the mounting done? Okay. Now, for you to be able to mount, remember, we need to be able to establish a connection. Okay. So we first of all have to be able to set up a logical connection between the server and the client. And then after that, of course, we need to be able to know this is very, very important. We need to be able to know which name of the remote directory to be mounted. And that's why you remember on the previous diagram, we say we had the two clients mounting a particular subdirectory. So that's what we are saying. And of course, we need to know the server machine that is has that information. So for me to mount, I need to know the server, okay? Supposing I'm the client, I need to know the server. I need to be able to know the remote directory, okay? And of course, we'll talk about the network file system that is used. And then, of course, I can apply remote procedure call, okay, forwarded from the mount server to the server machine. So we'll see what a mount server is, okay, in a short while. But basically, you have to know that before you can be able to mount. And the server needs to have an export list. An export list says that I have all these files that I can export for mounting. And it also means that it has to be able to say which of these files and I'm exporting for mounting and which machines can be able to mount them. So when they are sending out, it doesn't mean, when the export list is simply from the accreditation we talked about, it simply says these clients can mount and the rest of the clients cannot be able to mount. So it exports what we have a client list. So if you make a request, you want to mount, when you make a request, it will have to check the export list. And then the moment it checks the export list, then it gives you a file handle. A file handle simply gives you an opportunity for further accesses. Okay, because remember, when you mount a file, you have it, you're making changes to it, you can search it, you can maybe create subdirectory we need. So it has to give you further accesses. But remember, we started from having accreditation. So the file handle that you are given, okay, has a unique identifier. A unique identifier which will have an inode, remember, an inode, which is basically information node that identifies whether it's a regular file, whether it's a directory. So what we are saying, the export list will have a file handle, and the file handle might say, these ones are files, and these ones are directories. Now, if you're only allowed to mount a subdirectory, you can mount that. If you're allowed to mount a larger subdirectory, again, you can do that. So that is very, very explicitly stated, okay? So depending on which client. And so from here now, when you have that information, now it's possible now to mount a directory. And like I said, it only changes the user's view, but does not affect the server side. So the client will see, depending on the rights, access rights will have a different view because they were able to mount, and the user's view, the server's view does not change. Now, when we mount, we have the mount protocol. So, we have the NFS, which has a protocol to allow you to mount. So it means that it has to be able to understand whether you want to have remote procedure calls for remote file operations. So it has to provide you with a set of procedure calls for you to be able to access files. Now, the moment those ones that you have been given, then you are given procedures, of course. You can search, you can read, you can manipulate, access, read and write files. So with the NFS protocol, the moment you have been given, remember that you have a file handle, you can now be able to mount the files. You are given now the procedures that you can use, and now you have an opportunity to be able to do all these things here, okay? And the things that you can be able to do on your local files, your local subdirectories, your local directory, you now have capability, you can do that. So we end up now, what we discussed earlier on, and we say, now you can see, the NFS file servers are stateless, okay? So each request has to be robust. Quite robust because it has to be able to handle all those arguments. Of course, one problem with that is that it does not provide concurrency control. Remember, concurrency control says if client A is changing a file and client B is changing a file, if it's the same file, it does not provide that all of them will be handled together when that report comes back to the server. So we must have a mechanism for concurrency control. Concurrency control says we are trying to do something at the same time. Okay, so it does not have that. So if you bring that information back to the server, potentially whoever sent last might have might override the results that were there previously. So the implementation of the NFS protocol utilizes 3 ways that makes it possible. Okay, so we have 3 different layers. We have a system call layer, a virtual system layer, and the NFS service layer. Okay, so what we are talking about was the one that was providing the protocol. So remember in the previous slide, which was talking about the procedures for remote file operations. So that is the service layer. We'll see a diagram in a short while. So the system call layer is what it does. It basically does the basic primitives: open, read, write, close calls, okay? And file descriptors. Remember, file descriptors, we say, describe information about the file, the inode, the offsets of that particular file, where does it start, in which blocks does it start. So it basically acts keys to access files. Okay, now, so that is the system call layer. We'll see in a diagram. And then of course we have the virtual file system layer, which now comes in to be able to distinguish. Remember, you are having this implemented on your local local node, which is a local computer, and you are trying to access files that are there on a remote location. So it does not, you still have to use maybe local files. So NFS comes in, the virtual file layer, a virtual file system layer comes in and says, I want to be differentiated. These are local files, and these are remote files. Okay, so in this case, what we end up saying, so this one will have to distinguish. This one will have to distinguish which files are local, remote, or which ones are remote, and which ones are local files. So it means that the virtual file system has to be able to have a scenario that will be able to identify those differences. Yeah, so those differences between local files and remote files, this is handled by the virtual file system. So the remote will go through the remote procedure calls, of course, like we are saying, and it is being supported by a network file system. Local, of course, the same, you have your operating system, the local scenario, so it will do it the same way it does locally. So in a diagram, this will look something like this one here. Okay, so we have, as we start, we have the client here, and of course we have the server here. Now, so then we have this part here where we started, and we said, this is the part that has the system call layer. So the system call layer, which basically means the opening and closing of files. Remember, system call layer, we are the upper part, if we look at it from the application. Okay, and then now we have the next part here, which is where now the virtual file system. And this is where we said you have your local files, maybe for example, you might have Unix files, okay, on your local disk, for example. So these are local files. So the whole of these ones here, the whole of these are examples of local files that you have. But then it also has to help you think about remote files. So if now you have to think about remote files, you have to go to the remote network file system client, which will run on top of a remote procedure called external data representation. It goes through the network, goes to the remote procedure call and the external data representation, the server on that location, and then of course it can go to virtual file system before the server can be able to handle that. So the whole process means that when you're working on it, you have to think about which one are local files and which ones are external files. So local files will be handled here. So these are the local files. External files will have to go through this procedure here, where it comes all through the network, goes through there, and then go all the way back all the way to the client. So that's what we said earlier on, that it has to differentiate between local and remote files. Okay, and so from our previous slide, what we end up with, we are saying we had first, we had this for opening and closing, this to differentiate whether it's local file or remote file, and then this one to ensure if it's remote file, it goes through the procedure all the way until we get back to the server. And then of course the result will come back later on. And remember, we have mentioned this before. We have mentioned this before, that the external data representation will take care of that. So if you send in one form, the data in one form of architecture, processed by a different architecture, the external data representation will handle back that, and then you can be able to come to that location. So I think, I have one slide before I pick questions. I have very little time left, but I think I'll have time to answer one or two questions. So the remote file, network file system, when it's using remote files or remote operations, has a structure that has nearly one-to-one correspondence with the Unix system calls. So the way the Unix behaves is how this, so network file system, basically the structure is based on Unix in terms of the way it works. So except when it's opening and closing file, because that is handled by the system layer. It also adheres to the remote service paradigm, which employs buffering and caching, okay? So buffering and caching are basically the same concepts, okay? Buffering, if I'm buffering something, it means that as I'm bringing the information, my storage location has a way to be able to keep on storing this information until I have enough information that I can be able to process. And it allows for you to be able to interact with slow or fast servers. So if something is coming from a fast server and my computer is slow, I need to be able to buffer so that it keeps on accumulating so that my computer can process. Similarly for the server. So it usually takes place when you have two different nodes that are different speeds. Caching is what we have discussed before, where you store the entire file. So this therefore means that caching and buffering are there to ensure that we can be able to handle performance. And usually it's about the differences of the two different nodes. File blocks, when you are opened, the kernel checks with the remote server, okay, whether it can be able to fetch or revalidate cached attributes. So for every file that is cached, we have cache attributes. Attributes are the information about that particular file. So we can be able to check again, do we have any changes on the attributes? So if we have changes, can I be able to invalidate? Invalidate, say this file is no longer useful, or this information is stale and I need to be able to get a new file. So that is what we mean cache attributes. So it uses that. It keeps on checking to ensure that that is done. The file attribute cache, this is updated whenever there is a new information that arrives from the server. So the server might tell the client, hey, you know, this particular file has this particular problem, so it's stale, can you change it or throw it away, get a new file? So that means that we have to change that particular file. And clients do not free delayed write blocks. Now, remember, when we talked about the delayed write, we said that the client will have to work on it and store the information later. So it does not free delayed write blocks because until it confirms that the server has written back, okay? Because you remember, if you do that, you will actually lose that information, okay? And so that means that we end up ensuring that any information that was cached on this client side is not lost because or when you are trying to save that information back to the server. Okay, so I think let's pick one or two questions before we end there. We had a question. Okay, so someone was asking, is access the only thing that becomes transparent? Now remember, the setup, I think, Julie, what I'm saying, the setup itself, for you to be able to set up, you need to know the server, you need to know the file, you need to know the directory. That has to be non-transparent. You must know them. And then now, subsequent accesses become transparent. So let's put it this way. So the setup itself for mounting must be non-transparent, okay? It's non-transparent. And then now the accesses become transparent, subsequent accesses become transparent. Okay, so I think I want to end there, but I had just a few things. There are some questions about the e-learning, so I'll pass there tomorrow to see if I can be able to change. I think I had set up so that it accepts only one file, so I can change so that it accepts multiple files, so that information can be there. Hey, someone has reminded me something. I don't know how I missed that one. Let me just go there. Sorry about that. Just 1 minute. Oh, yeah. I had, yes. Sorry, thanks for that. So the path name translation. Remember we have said that when you have a file, you need to know the server, directory, subdirectories, and so forth. So when you are trying to find which files that you need to access, you need to have what we call path name translation. Path name translation means that I have to go directory, subdirectory, and so forth until I get to the virtual nodes, which are basically the internal representation of a file or directory. So that has to be done component by component. Okay, component by component, making sure that if I am at the top level directory, can I be able to go to subdirectory and so forth? That's what it means by path name translation. So the moment you have done that, we have the V nodes, virtual nodes information is stored, and therefore the lookup information that you had. So now on my cache, I have, this is directory, these are the subdirectories, these are the files. So the lookup now becomes very easy because now I have the information that is already translated. I can easily be able to, remember when you have the nodes information, okay, I can easily be able now to go to a specific file because instead of now translating path by path from subdirectory all the way, I now can be able to jump directly to it because I have that. As the way the Unix maybe system and file servers work, the moment I have the inode information or vnode information, it means that I can easily be able to jump to the blocks. So some of the things that we might have discussed in terms of computer organization. So I can easily now be able to jump to where that particular file because I have that. But if I don't have that information, I will now I will have to do what we call path name translation. So I have to go file, subfile, directory, subdirectory, and so forth and so forth. So the moment I do that, it makes it easy now for things like the seek method. Okay, so I have now an offset. Offsets are now stored. I can easily be able to move from one block to another block because I had already done path name translation, and that is easier now. Okay, thanks for reminding me about that. I had jumped that is an important point. So it makes it easier, and that is one of the techniques that NFS uses to make sure that the moment you have now mounted files or you have a remote file access, the moment you have done path name translation and stored the inodes and vnodes, vnode means volume. So your volume means a group of files. So if, the moment you have stored the volume nodes and the inode is about a particular file. The moment you have done that, it is very easy now to be able to do quickly be able to access files and move from one file to another as you implement, and that makes it easier for the whole process of a distributed environment to work. Okay, so thank you very much. I will stop there, and there are some things I will be able to update tomorrow when I usually do that when I'm in the university. And when I do that, I'm sure those who are not able to update files, you can be able to update, and then we can be able to proceed. So, and then of course, I will have now the other tutorial for the other communications, which is much shorter because communication, some of the things you have done in earlier programs. So this one will just be a very short one, but it is important for people to review so that they understand some of the concepts. So thank you very much. Have a good evening, and I'll see you on Wednesday.